In Chapter 9, Section 5, we are going to change some dimensions and then see what happens to perimeter, area, and volume. If you change your dimensions by some number, let's call it K, the perimeter and the circumference are going to change by that same number. However, with area, you're changing two dimensions, a length and a width. So that's going to change by K squared. And volume, you are changing three dimensions, length, width, and height. So that will change by K to the third power. Our first example is all about one dimension. We are only changing one dimension in the shape. So if we change the height just by 6, it's going to change the area by 6 because we've only changed the height. If we only change one of our diagonal by 1/3, it's going to change the area by 1/3. If just the height is tripled, our area will also be tripled. If just the length of a figure is doubled, the area will also be doubled. If just the base of a triangle is multiplied by 4, the area will be multiplied by 4. The height of a parallelogram is multiplied by 5, the area will be multiplied by 5. If the width is multiplied by 1/2, the area will be multiplied by 1/2. If just the height is multiplied by 3, then the area will be multiplied by 3. And if the radius of a circle is multiplied by 1/2, actually we're going to skip this one. On the next page, it says, describe the effect of each change in the perimeter or circumference and the area of the given figure. Now the base and height are both double. If the base and height are both doubled, our perimeter, is going to be doubled. But the area, we've changed both dimensions, the length and the width. So the area will be times 2 squared, which is times 4. If we multiply the radius of a circle by 1/5, the circumference is also multiplied by 1/5. But if we change the radius of a circle, we're actually changing the length and the width. So we're changing two dimensions. So the area of that circle would be times 1/5 squared, or 1/25. So the circumference stays the same. The area is times that number squared. Letter C, the base and height are tripled. The circumference will be multiplied by 3. But area, you've changed the base and you've changed the height. So your area will be times 3 squared, or times 9. Letter D, the side length of a square is multiplied by 6. The perimeter will be multiplied by 6. However, the area, you've changed two dimensions on a square, two different lengths. So that will be times 6 squared, or 36. Letter E, the base and height of a rectangle are both multiplied by 1/2. The perimeter will simply be multiplied by 1/2. Area, we've changed base and height, so we've changed 2 dimensions. So we multiply by 1/2 squared, or 1/4. Letter F, the base and height of a triangle are both doubled, so your perimeter will be doubled, and your area will be multiplied by 2 squared, or 4. And letter G, circle has a radius of 5. If the radius is multiplied by 4, the circumference stays the same, and that's multiplied by 4, multiplied by that same number. The area will be multiplied by 4 squared, which is 16. Example 3, circle has a circumference of 32. If the area is multiplied by 4, what happens to the radius? Well, this one we're kind of working backwards. We've said the area always has to be by that number squared. So if k squared, if we've squared that number and it equals 4, if we square root, then what we did to the radius is we multiplied that by 2. Letter B, an equilateral triangle has a perimeter of 21. The area has been multiplied by 1/2. What has happened to the side length? Well, this has been squared, so we need to square root both sides. And so we are left with k equals the square root of 1 over 2. If we simplify that, if we take the square root of 1, it's 1. And the 2 stays underneath the square root sign. You can't leave it like that, so your side length has actually been multiplied by square root of 2 over 2. And the last one, square has a perimeter of 36. The area has been multiplied by 1/9, so that's already been squared. To undo that, we square root both sides, and those are both perfect squares, so the side length then has been multiplied by 1/3.